Here's an example of a shadow problem, but we don't have a drawing, so we'll have to make the drawing ourselves to help us understand the problem. So a telephone pole casts a shadow. So pole, just a big, I'll just draw a big beam like that, casts a shadow that is 50 feet long. So let's say here's the shadow that's 50 feet long. And nearby, an 8-foot tall stop sign. Oh, I've drawn an octagon. That's too much, too much for me to draw. There we go. There's a 8-foot tall stop sign that casts a 10-foot shadow. Obviously, not a very good drawing because my 10 feet side length is about half of the 50-foot side length, but not super important. It's a bad drawing, I'll admit that, but it won't stop us from solving the problem, which is how tall is the telephone pole? So I'll call that h. Could use x as well, but I'll use h. So proportions of sides, I'll do, let's start with h since it's our unknown. I'll say h to 50 in the telephone's triangle with its height and its shadow. H to 50 is equal to, well, the equivalent in the other shadow case, which is 8 feet, the height of the stop sign, and 10 feet, the shadow of the stop sign. So that's 8 to 10. So now I can go ahead and solve this. I'll solve this one by cross multiplication. So multiplying by 10 on each side, and multiplying by 50 on each side, so that my 50s go and my 10s go, leaving me with 10h equals 8 times 50, which is 400. And then divide by 10, and I get h equals 40 feet. So h equals 40 feet is a perfectly acceptable answer. You could also write it out with more words if you want to say telephone pole equals 40 feet, or the telephone pole is 40 feet tall. All of those would be acceptable answers.